Part 2 of my Manta Mirage project, aka the McLaren M8 lookalike, is the power plant and the transaxle, in essence the drivetrain. This is an LS2 motor. It's a generation 4 small block Chevy with a 6-liter displacement. I've got a homemade individual throttle body injection system. The parts from it are sourced from the Chrysler LHS 48mm throttle bodies. I used 2 of them on their 3.5 liter motors. They're made by Hallett. Again, they're 48mm, so they were very simple with only a vacuum port, and that's all. So it lent well to what I was trying to do, so they were very cheap as well, $22 a piece, which made it very nice. So I grabbed a bunch of them at the salvage yard, made me an aluminum mounting plate for it that adapted the round ITB body to the rectangular manifold runner size. And the manifold is kind of different. It's a Edelbrock Pro Flow intake for the LS series motors. What I did was, it's basically a tunnel ram. It takes a long log ram that was at the top here with the throttle body, the OEM Corvette throttle body, but I cut the top of that off, welded a mounting plate to each of the top of the runners after I straightened the runners out a little bit, and you can see where I straightened them out, where I cut a wedge out of here and then scrunched it over and made it more vertical, and welded it all back together, and now I've got 8 individual ports that I was able to mount throttle bodies over each of the ports. Then I fabricated a throttle operation mechanism, and you can kind of see how it all operates. It seems to work pretty well. Don't have any throttle plates in it right now because I've got to modify the insides. McMaster Car provided the shaft connectors, so that worked out very well. And then a company that makes the stacks for the Hillborn fuel injection systems provided the stack here. Now that's a 12-inch stack. I probably won't use one that large, but I will have 8 of them on each one of these. Software indicates that actually somewhere between 8 and 9 inches on the stack itself will provide peak torque at the RPM I'm looking for. Outside of the induction system, I'm using Ford rails. They just happen to line up pretty well with the LS series as far as bore size or bore spacing. And then below that is the headers, and these are 1 3/4 inch, 180 degree, semi-equal length. I try to get them as equal length as I could, but it's hard to do when you've got the collectors separated on each side of the transaxle. If they could have been mounted closer together and up over the top, would have had an easier time making them equal length, but that was not possible because the M8 bodywork comes down real low across the top of this bar here, so I had to keep the header heat as far away from the fiberglass body as possible. But that was probably the most labor-intensive part of the whole car, was the fabrication of these headers. Very hard to do. But they're done, so I don't have to worry about them anymore. The uprights, that was another challenge, was fabricating these uprights. They look a little archaic. They've got a lot of square tubing. You can buy aluminum ones, but I wanted something that was pretty common as far as parts usage. The outside uses GM or dune buggy micro stub parts, so a GM bolt pattern on the outside with a Porsche 930 CV joint inside flange, so it all worked out real well. Allows me to use some pretty commonly used parts for racing instead of some of the harder to find parts that come with the aluminum original type design uprights. The suspension configuration is very similar to the Sports Racer or GT Ford. Back then, it's an inverted or reversed wishbone bottom. It's got the long trailing arm up on top right here that runs to the firewall. Has another one on the bottom side, so that controls the suspension. Again, QA shocks on the back. This is a 260 pound/inch spring. And again, the bar that goes over the top of the headers is going to be roughly about 1.5 inches below the bodywork. I'll be putting a sway bar on top of that bar as we go along. A lot of details have not been worked out. I kind of work from the concepts outward, and so in this case I've got a lot of the basic stuff finished. It just needs to be detailed and fine-tuned to get it just right. The transaxle is a Porsche 930 transaxle. They say it's good for anywhere between 500 to 700 horsepower if it's not abused. So I think I'll be in pretty good shape. I've seen a lot of guys with V8s use these as as the economical choice between that and going with the full ZF or Ricardo or any of the other well-known V8 transaxle manufacturers that are probably 2 or 3 times the cost of what this transaxle cost me. Tires, 315s in the back. I plan on changing that to 335 as I go along because I needed really a taller tire. The wheels are image wheels. They're copies of Hallett, and it's a knockoff of a knockoff. In other words, it's the center lock system is really a fake center lock system, but they did a real good job on making it look like it's the real thing. So I was real happy with that. Brake rotors are all 4 sides, all 4 corners are Corvette C4 rotors. Are 12 inches in diameter, and I use an Outlaw 4-piston caliper. It's the same one on all sides. With the current weight distribution and piston size and information that I've put into some software, it indicates that I can get away with all 4 of them the exact same size as long as I keep around a 60-40 weight distribution on the car. Steering off the rack, it's just tacked in right now. This is a Porsche 920. Let me say that again, a 911 steering column, and again it's just tacked in place. Very quick steering. I think it's less than 2 turns lock to lock, so I'm worried about maybe being a little darty once I get it going, but we'll find out. So that's about it. That's the McLaren project as it sits right now in the summer of 2009. Plans for the next couple of months is to get, which has been on back order, the Aeromotive fuel pump and get it tied into these lines that I've already got sitting here ready for them, and that comes out to this Y, goes up to the injection system, and then the regulator will come off the outside of that and come around to this tank over here and go back into the swirl pot. So it's got quite a bit of work done for the fuel system. The low pressure pumps off of each tank are located in the corners underneath the seat. Both those low pressure pumps feed through a low pressure line. That's what the black is. It's just regular hose that uses the compression fittings. The passenger side tank comes to this tank and continues on to the swirl pot, which is about a 5x5 aluminum tank. And from the swirl pot it picks it up, goes back over to the high pressure pump that will be in that container, back out to the fuel injection system and out this fitting to a regulator, and then it'll go back to a bypass, or back to the swirl pot. So it's a continuous loop there through the swirl pot. I'll have to have one-way valves on both of the low pressure pumps. Make sure I'm not feeding back from one tank to another accidentally. And once I get through with that, finish up a little detail welding and get a system set up for the alternator. I had to shave the alternator bracket about 1/2 inch on the back to get it lined up with the Corvette stuff on a lower bracket. Get a tensioner designed and built for that, and I should be good to go. So that's my project. Body work will probably get started next year.